And if we falter, we should now be able to easily identify that we've come back up. We need a single metric for that. So, Mark, get that done, will you? Yeah, there you go. And also, the certification really should mean something. You can lose that certification, and it should be a stamp that you're actually doing the right thing. Okay, in engaging with these groups, as Mark was saying, we've definitely got to get together with them and come up with how that looks. The stack, as Graham and Jeremy mentioned, this is also extremely important. Because if you're looking at the entire data center itself, we've got lots of ways to approach it. You take the uptime tier levels. That's for the M&E portions of the data center. Then you've got a number of other layers on top of that that have their own little metrics in there. But we would like to have one stack that we can all agree upon and come up with approaches for that of what is the efficiency across the board. But we need to define that stack as an industry, as a user base, and understand how we can apply it to our data centers. Now, there's a lot of work around this, and I'm sure Graham and Jeremy are going to be spending quite a bit of time on it, but the key is you should be able to come up with something. If we want that one top-level metric to be able to measure the efficiency of that, there should be a lot of other components under that that feed it, one that rolls up to it. Okay, this is another one, and Ken Brill, I apologize from the beginning. We either need to update those tier levels themselves or we need to dump it. It's the data centers are truly moving forward with the technologies, rapidly moving forward. The problem is that the tier levels don't seem to be keeping up with that. It's just expanded, but the problem is it was a guideline initially, and it's really turned into a standard. And that standard isn't really truly looking at the entire portfolio of technical infrastructure inside of a company. So, for example, at Sun, 8% of our portfolio is IT and 92% is engineering. Okay, so we're trying to apply tier levels, but I would like a tier 0 level definition within it. Okay, also there's just a complete mismatch. I don't know when this happened, but the tier levels for the data centers and then the tier levels for applications are completely reversed. So tier 4 is great in the data center from the physical side. Tier 1 is great for an application. Tier 1 applications are mission critical. So there's just a disconnect within that. How can we come back with one way to look at the holistic data center, again, across that data center stack? Also, the mixed environments, we don't really, as you heard, the modularity components, we'd like to be able to snap in things where we need. You can have a data center that has tier 1, 2, 3, and 4 in it. Why not? You should. Because if you don't, you're over-provisioning everything because you said, oh, I better need a tier 4. When in actuality, I should be making more resilience in my applications and creating the tier 2 data center. All right. Modularity, we keep pushing this. We want more modular products from you guys. I do not want to continue to over-provision data centers because it could be coming. And if you look at what we try to do in ours, it's about snapping in components. We need more solutions. We need more answers from you guys around modularity to say, how can I go from everything at the rack level all the way back out to the plant? If I can do that, I suddenly control my business and I enable my pace. I can go a lot faster and I keep my costs under control. So modularity is extremely important to our user base, as you've heard from the different speakers today. The simple top-level efficiency metric, as we were saying, we want one metric. We want one simple way. And we keep talking about miles per gallon. And the other one, just think about you roll in your car every year and you do a smog check. And Mark talked about this. What's a smog check in a data center? Do you really meet it? Do you actually meet the minimum requirements for that data center to be efficient? We should be able to compare that and actually do that. So that top-level metric is extremely important. It is okay if it's a roll-up of a bunch of metrics, but we need to define what that is so we can have one answer in there. I want to be able to go back to my executives, the ones who pay the power bill, and say, yep, we meet the 72nd percentile of efficiency within the data center market in our implementations. And by the way, next year, my goal and my bonus is based on me hitting 80. We should be able to do that. But we've got to get together and come up with a standard metric to be able to accomplish it. Okay, last thing on that one is it is important that we actually compare. Okay, I don't care what people say. I really want to know what my PUE and my other metrics are against Google, against Microsoft, against all of them. We should, because all it does is drive innovation and more efficiencies in the data center, and it's healthy competition. We all are generating carbon, and we're all consuming electricity, and we should all be showing how efficiently we're doing our data centers themselves. Okay, end-to-end IT and facilities measurement. Bob was talking about this. A common communications protocol. I love the idea of a server, the IT side, being able to say, I'm drawing this much power. The PDU that is plugged in is saying I got this much. The aggregate of all the rows in that or the racks in that row, all the way back to the UPS, and we see all the way through the line that it really makes it. And we can now see the opportunities are popping up because we've got a way to communicate all the way through that chain. Today we really don't have that. We've just got disparate systems that are reporting on different components. And the interface between the IT and that equipment, right now, we've got to connect that. The building management systems to the IT-specific systems. We've just got to connect those pieces. It needs to be agnostic when it comes to the vendor products themselves. There should be a standard protocol that enables this. It shouldn't be that we've got one thing from this company and another from this company. We've got to write interfaces to try and make them all come together. We shouldn't have to do that. Come up with a standard protocol, right, and be able to report on it. Okay, conductive cooling. I love this one, as Phil was saying. I want to mention that in that test that we're doing for the chill-off, we're breaking our own warranties. It's an experiment. We're literally going in and seeing what's going to happen. And that is what really pushes things forward. Because we're going to build a rack in that chill-off and see how much we can drop from the fans themselves. But if you think about what the vendors would do, so from Sun, HP, Dell, and all of that, they could go off and develop their own standard and build all these different products and individual things, and then you're going to have the same problem. I buy a Sun rack like this, I buy an HP rack like this, an IBM rack like this. And when you've got hundreds of thousands, if not millions of square feet of data center space to deal with, how do you design the infrastructure to actually deal with it? Do I go water? Do I go refrigerant? Am I going to go CO2? Am I going to have to do all three? Point being, if we can have a standard interface in which we can now say, fanless servers or any device that takes advantage of this thermal interface will plug in this way and have these operating characteristics. And we do believe that functions such as ASHRAE and others can help define that standard. And then the actual vendors could apply their products to that standard or work within that standard for the new products. Because all it takes is somebody saying they want it. And right now we're telling you that the data center industry, the people that buy it, are interested in passive type solutions like this. We want to get rid of air everywhere we possibly can. Number 9, you heard this one too. The 480 volt, 277 volt servers. Okay, so for all the engineers out there that are actually doing power supplies, we apologize again, but you can do that. I'm sure you can figure this out. You're smart guys. Come up with an answer that we can plug in a 277 volt server and let us get rid of one transformer loss right in the middle of our data center. We should be able to do that. It's just more efficient. Okay, the other part of this, the people that are designing the products that those servers plug into, of course we're going to need the PDUs and other things to support that type of voltage. Okay, and I think there's some of that out there already. It's the server side that's going to have to do a lot of work, I think, to make it happen. All right, the last one is we want to create a repository. So I'll tell you, I walk in and I want to go back and find out how efficient that server is to that server. Well, they say, well, it's an HP and it's a Dell. Okay, well, let's say the same servers. Well, that one's got an InfiniBand card, and this one's got an extra drive, and that's an extra power supply, da, 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 da. Okay, so I still can't compare what I want to compare. We would like to go back and now think of it as a phone home type thing, that our users are able to say, send this snapshot information to this database. It is this type of server with this hardware in it that actually is consuming this electricity over this time, and it has a nameplate version of this. That would be really interesting information, because I can go back and look at mine and say, yeah, that does make sense. Okay, why am I getting such inefficiencies in my servers here when my peer in the industry is getting this high level of efficiency? Or that server product actually looks pretty good, or that storage solution. We'd like to have a repository. So that's one piece of it, but you can see there's so much other content. There is no place today for us to go back and get information without having to go through the web and dig up everything. Right? Trying to find design information, trying to find about how efficient the cooling devices are. Which server should I buy? Which virtualization solution should I put in place? It'd be great to have a repository of that information that our user base could actually take advantage of.